All right, the first section on Unit 2 is looking at rectangular coordinates and graphs. You can pause the video to write down these formulas. The Cartesian coordinate system was developed by René Descartes, Cartesian. It's the rectangular system that we're used to, the XY plane. Remember that we label our quadrants starting in the upper right, and we go counterclockwise, quadrant 1, 2, 3, and 4. The first two formulas, distance formula and midpoint formula, you've probably seen these before in an algebra course. But I want to discuss a little bit about where they come from. The distance formula basically says if I've got 2 points and I want to know how far it is from one to the other, essentially I'm going to subtract their x distances. If I subtract their x distances, that's going to basically give me this length here from how far horizontally it is from one to the other. Then it says, hey, let's subtract their y distances from each other. That's going to really give me this distance, the vertical distance between the two. Notice that it really just creates a triangle. Basically, distance formula is an application of the Pythagorean theorem. The x2 minus x1 squared is a squared. The y2 minus y1 squared is b squared. You would add those together and then take the square root to be able to figure out c. So really, distance formula is just Pythagorean theorem. Midpoint formula basically is taking the average. If I, for example, had test scores of 70 and 90, we'll go with easy numbers. If I said, hey, what's your average or what's in the middle of those? Yes, you know it's 80, but you could add them up and divide by 2. That's really what you're doing. You're adding the x's and dividing by 2. You're adding the y's and dividing by 2. You're finding the average of them. That's what's in the middle, hence midpoint. So formulas you will have to know, but we'll use them several times. So distance formula clearly takes a lot longer. Find the distance between the points. If it helps, you can label them x1, y1, x2, y2. So for distance, big long square root, x2, so -2, minus x1, quantity squared, y2, 8, minus y1. Now be careful, that's going to be minus -5. So in the first parenthesis, that's going to be -5. That's a -5 squared. -5 squared is 25. Be careful, in the second grouping, that's going to be 8 minus -5 or 8 plus 5, which is going to give me 13 squared. 13 squared is 169. If I add those together, I get 194. Now, if I could do a factor tree and break that down, I would, but it doesn't do anything. The factor tree doesn't produce any pairs, and so that's as far as we're going to go. So that is the distance between those 2 points. Now, that's using the distance formula. I also want to show you that, again, really distance formula is Pythagorean theorem. So here are the 2 points on a graph. If I build a little right triangle on these, the horizontal distance, well, if I count the amount of spaces, and again, I'm looking at the bottom of this triangle, the horizontal distance, it's that 5. That same 5, yeah, we had a negative, but who cares that we had a negative because we squared it anyway to make it positive. The vertical was 13, we found out. If you count the amount of spaces bottom up, it is 13. So really, 5 squared plus 13 squared is c squared. We'd end up with the same thing when we took the square root to get c by itself, or the distance. For the midpoint, this one's even easier. We add the x's, so x1 plus x2, so I'm adding a -2, which would really mean I'm subtracting 2, divided by 2. Add the y's, y1 plus y2 divided by 2. So I'd have 1 over 2, 3 over 2. You could leave them like that. You can make them decimals. But remember that the midpoint should give me an x and a y. It's a coordinate, or coordinates, excuse me. It's an ordered pair. So 1/2, 3/2, just to kind of get a feel for if that seems right. 1/2, 3/2 would put me right about here, which, yeah, those distances, they look about the same. That looks like that's in the middle. So again, it's not precise with that, but it gives me an idea. For number 2, we have a very kind of strange, different sounding problem. Determine if these points are collinear. So just a reminder from geometry, collinear means on the same line, together on a line. Well, how the heck are we going to do this? What does this have to do with distance and midpoint? Well, it actually is going to use the distance formula. So graphically, we've got these points, and the question is, are they in a line with one another? Now, granted, by just looking at it, looks like they are, but that's not mathematically precise. Here's what could be happening. I could have a point, that other point could be kind of off to the side just a little bit to where they're not in a straight line with one another. Here's how I'm going to figure this out. And it actually is going to use the distance formula. If they are in a straight line with one another, then this blue distance and this green distance should add up to the whole distance across if they're in a straight line with each other. So the two little pieces should add up to the whole thing. If, however, they are slightly off from being a straight line, then the blue distance plus the green distance is not going to be the same as the distance from one to the other, because it's going to be in a triangular shape then. So what we've got to do is figure out the distance between the points. So this is going to be several distance formulas here. So what I'm going to do is I'm actually going to mix it up. I'm going to do distance formula for the distance between P and Q to start off with, but then I'm going to use different ideas for the other ones. So from P to Q, I'm going to do x2 minus x1. So that's going to be 2 minus -1. Oops. Some terrible writing here. That's all going to be squared. Plus y2 minus y1 would be -4 minus 5 squared. So the first parentheses, that's going to actually be 3 squared, which will give me 9. This will be -9 squared, which will give me 81. That gives me root 90. And if you break that down, that simplifies to 3 root 10. Okay, so there's the distance from P to Q. Now, you could keep using distance formula for these other parts, but I'm going to try something a little different. That's a little faster, I think. The next one I'm going to do is from Q to R. remember, what I'm really finding out is how far away the x's are from each other. So if I'm looking at Q and R, from 2 to 4, that's a distance of 2. That would be like a leg of a triangle with a length of 2. So I know it's going to be 2 squared. Then ask yourself, how far is it from -4 to -10? From -4 to -10 is a distance of 6. So that's going to be the other leg of the triangle. Again, think of it as like Pythagorean theorem. That would give me 4 plus 36, which is 40. So root 40, if you break that down, that is 2 root 10. Okay, so what have we really done? Let's look at the graph again. I figured out that from P to Q, that distance was 3 root 10. I figured out from Q to R, that distance was 2 root 10. Now for the last step, I'm going to find the distance all the way from P to R. And if that's the same as these two added together, they must be in a straight line. So now I've got to do from P to R. And I'm going to do it the same way I just did the previous one. Again, you could use distance formula if you wanted. But let's think about this. From P, x, so -1 to R, 4. From -1 to 4, that's a distance of 5. From 5 all the way down to -10, that's a distance of 15. So you'd have 25 plus 225, which is the square root of 250. Which, if you factor tree and simplify it down, it is 5 root 10. So ask yourself, does 3 root 10s plus 2 root 10s equal 5 root 10s? It does. So are these points collinear? Yes, they are. They're in a straight line. That is by far the toughest problem on this section. Number 3 is another midpoint problem, but this is a little bit different. I'm given the midpoint, M, and one of the ends, P, of some segment. I need to find the other end. This is going to be a backwards problem. So normally I would do x1 plus x2 divided by 2. That would give me the x coordinate of the midpoint. Well, in this problem, I have one of the x's, -6. So this is going to be -6 plus, I don't know the other x coordinate, divided by 2 is going to give me the x of the midpoint, which was 8. So I've got to solve this algebraically now. If I multiply by 2, that would give me -6 plus x2 equals 16. Add 6 over. x2 is 22. Now I have to do the same thing with the y's. I know one of the endpoints, 12. I don't know the other y. I'll just call it y2. But I do know that dividing that by 2 should give me -2. So I'd end up with the equation 12 plus y2 equals -4. If I multiply the 2, subtract over 12, and you get that y2 is -16. So the coordinates of point Q must be 22, comma, -16. Number 4 is actually another application of midpoint. The graph is depicting the revenue from 1990 to 2014 for fast food restaurants. Notice they went in a nice straight line. Approximate the revenue in 2002. So here's the key part of this. 2002 is actually dead center between those. It wants the revenue, that's the y coordinate. So basically it's saying, hey, I already gave you the x coordinate of the center. What's the y coordinate? So that point is 2002, comma, something, and that something is what we need to figure out. Really, all this boils down to is knowing that the midpoint is really just the average. So I'm going to average those y coordinates. Those are the y numbers. So if I average those, oops, 0.1, divide by 2, that'll give me 132.45. This is in billions of dollars. So again, it was just a fancy word problem way of saying find the y coordinate of the midpoint. Now we're going to get more into the graphing stuff. On number 5, A and B, we're finding the intercepts to graph these lines. Now you've done this before, most likely. Remember, the logic here is if I'm hitting the x-intercept, I'm sorry, if I'm hitting the x-axis, wherever I'm hitting the x-axis, wherever I happen to be hitting the x-axis, that y-coordinate is 0 no matter what. So logically, to find where I hit the x-axis, I'm going to substitute 0 for y. So on 5A, to find the x-intercept, I'm just going to plug in 0 for y. So if I plugged in 0 for y, this would just turn into 3x equals 6, and so x is 2. Now, make sure that you give me this as an ordered pair. That is 2, 0. So my x-intercept is 2, 0. I'm going to do the same thing for the y, except for the y, I'm going to plug in 0 for x. So if I plugged in 0 for x, the 3x is gone, and I've got 2y equals 6. The y is 3. Now remember, the coordinates there are 0 for x, 3 for y. Since these are lines, I only really need 2 points. Connect the dots, and you got yourself a line. Now, this whole intercept thing, yes, you can use it on other graphs, but it doesn't give you a full picture of the graph unless it's a line, because you might have something that's got curvature to it if it's something besides linear. Same logic on letter B. The x-intercept, I'm going to plug in 0 for y. Now you got to do a little more work here. So if I popped in 0 for y, this would be 0 equals 5x minus 20. Add over 20. Divide by 5. So my x-intercept is 4, 0. For the y-intercept, plug in 0 for x. So that will give me 4y equals negative 20. The y is negative 5. So 0, negative 5 is my y-intercept. Since it's a line, just connect the dots. And we're good. Now, another way to graph stuff is to make a table. And we will learn tricks to graphing these later on in this unit. But for now, we're just going to stick with tables, which is probably the first way you learn how to graph. This is a parabola. And again, you'll learn to recognize that more later on if you don't know it. But since it has an x squared, it's a parabola. I've already given you some x's, so if I pop those in, -3 squared, remember that's going to be +9 minus 4, 5. If I plug in 0, 0 squared minus 4, -4. If I pop in 3, 3 squared minus 4, that's the same thing. I'm going to get 5. And so I can plot my points here. -3 up 5. 0, -4, and 3, 5. And remember, this is a parabola, which is that kind of U-looking shape. It looks something like that. For letter B, this is an absolute value. Absolute values look like a V. They come to a point. Where parabolas had a curvature, absolute values come to a point. Now, be careful. When I plug in the -8, what some students will want to do is say, oh, so that's +8 because it's inside an absolute value. No. Do the stuff inside the absolute value. That would be -2. And then take the absolute value. So the answer would be 2. If I plug in -6 for x, that would be the absolute value of 0, which is 0. If I plug in 1, that would be the absolute value of 7, which is 7. So if I plot these points, I've got -8, 2, -6, 0. Oh my, let's try that one again. And I have 1, 7. Now, we'll learn later on to know for sure, but the point -6, 0 is that point of the absolute value. We're going to shoot off from that point. For the last one, we have a cubic. Again, I'm just plugging in the points. So -1 cubed minus 1. Careful, -1 times -1 times another -1 would still be -1. I have -1 minus 1, -2. If I plug in 0, 0 cubed minus 1 is just -1. If I plug in 1, 1 cubed minus 1 is 0. And if I plug in 2, 2 cubed, careful, not 2 times 3. That's 2 times 2 times 2, so that's going to be 8. Oops, should be minus 1. 8 minus 1, which is 7. And so if I plot my points, I can draw a cubic, which you may not know exactly what a cubic looks like. That's fine. We're going to see one here. After I plot my points, a cubic looks kind of something like this. So this graph is way down, does a little curve there, and shoots up through that other point. So there's an example of a cubic.